So we're just going to follow these 4 steps for each of these problems. We're going to do 3 examples today. So let's start with noting excluded values. So when I say excluded values, that would be any value of x that it would break the equation. Are there any values of x that would break this equation? Where are you looking? What could potentially get broken in this equation? We got fractions, right? We know fractions can cause issues if we end up with a 0 in the denominator. Is there any way I can put a certain value of x into this equation and end up with a 0 in the bottom of any of these fractions? No, so we're good. So there's no excluded values. So I don't think we're going to have extraneous solutions, but we'll double check when we do come up with our solutions. So, all right, so number 2 is bust fractions. You guys, did you learn fraction busting back in the day? Fraction busting. So the idea is you're allowed to multiply everything in the equation by anything you want. If you're clever about what you choose to multiply everything by, sometimes you can make all your fractions cancel out. So what could I multiply everything in this equation by? 7. 7 would be a good one. So I'm just going to multiply by 7 here and here and here. And those 7s are just all going to cancel out. So all that would be left would be 2x plus 11 plus x plus 9 equal to 5. Do a couple steps of algebra, solve that. And then we'll check our solutions. Coming up with -5. Anybody try plugging it back in to see if it works? So back in algebra 1, well, maybe not you guys. You had Edgenuity, didn't you? Did Edgenuity teach you to? Probably not. Did anybody ever teach you that you could substitute a solution back into the equation to see if your answer was correct? Yeah, you guys know how to do this, right? You put -5 in for all the x's. And what you're looking for is to get the same number on both sides of the equation. So let's see if this works. That would be 1/7, and this is going to be 4/7. And hey, those do add up to 5/7. So we did it. We found it. Do you guys know your graphing calculator will solve equations for you? Oh yeah. You want to know how? We can check this with our graphing calculator. Yeah, any equation ever, your graphing calculator will solve it for you. Kind of. So let me show you how it works. So here's the deal. And we're going to use this to check this. We won't use the graphing calculator to solve the equations for us. We're going to use it to check. But I'll show you how you can. So go back to your original equation, and the idea here is you want to get a 0 on one side of the equation. So do some algebraic manipulation. In this case, I would do like -5/7 on both sides. Can you guys write down what that equation would look like? So if you're trying to solve an equation with the graphing calculator, you got to get a 0 on one side. And then what we're going to do is we're going to take a look at the function that's on the side that's not 0. We're going to look at that function. We're going to graph that function in our calculator. And what are we going to look for? We're going to look for x-intercepts. Why are we going to look for x-intercepts? What are the x-intercepts of a function? What do they correspond to? The zeros. And what is a zero? A zero are the values of x that make the function equal to 0, right? So the solution to this equation should be the same as the zeros of this function. So type this into your calculator under y1. It's going to be kind of messy. Don't forget that you do need parentheses around any part of a fraction that has more than one number or one variable. And then go ahead and graph it once you get it typed in. Now, we thought our answer was -5. Are you seeing a graph that makes you feel pretty good about that answer? I am. And we know how to confirm, right? We could do our whole second calc value and punch in -5, make sure it comes up with a 0, and it does. We're good. Huzzah. All right. You guys didn't know that before? Oh man, that's super useful, isn't it? Any equation ever. Any equation ever. All right, who's got questions on this first one? Any questions? All right, here's example 2 out of 3. This one we're going to do 3 over x plus 1 over x plus 2 equals 5. All right, now let's practice this. We're going to solve this by hand, but let's try this thing. I told you that you can solve any equation ever with your calculator. Let's try to solve with the calculator first. We'll know what our answer is going to be, and then we'll see if we match that if we do it by hand. So we would need to get a 0 on one side. Are you guys able to look at this and just say like, oh, that's going to be a -5 when we move it over here? So let's go ahead and type in what the equation would look like if we got a 0 on one side. Your graph looks something like mine. What I typed in is this equation if I had gotten a 0 on one side. So instead of equal to 5, I did -5. So if we got a 0 on one side, it would be 3 over x plus 1 over x plus 2 minus 5 equals 0. It's not x plus 1. It's 3 over x. And then plus 1 over x plus 2. But you're right. If I was trying to do an x plus 1 on my denominator, I would want some parentheses around that. All right, so how many solutions are we expecting to get when we solve this thing? 2. Can you give me a decimal approximation of those 2 solutions? I would like your decimal approximation to the nearest 10,000th. Could you do that for me, please? I want 5 decimal places, and I want all 5 of those decimal places to be accurate. Can you do that? Do you know how to do that? Your calculator will do that for you. What are we going to use? What function in our calculator can we use? Table's going to get you within one whole number, unless you start messing with the table setup. Trace is not going to do it for us. No, trace is locked to the pixels. Second calc, 0. Right? We're finding the zeros of this function. It's going to ask you for that left bound, right bound guess business. Remember, when they say left bound, they're looking for a point to the left of the intercept. Now, this is going to be tricky because I don't want it to go down negative. How am I going to deal with this? What I'm going to do, before I do this, I'm going to go in my window. And I'm going to shrink in on the x's. I know that my intercepts are they're all between -2 and 2. So I'm going to go to my window. I'm going to make my x min -2, my x max 2. This is going to make it a little bit easier for me to do that left and right thing. Okay, so now second calc 0. Left bound, I need to go a little bit to the left of the intercept. That's good. Right bound, a little bit to the right, and guess. And I hope that you're coming up with -1.849. Yes. See if you can find that second one. If you're struggling at all with this, please let me know, or ask a neighbor for some assistance. 0.64899996. All right, those don't look like rational solutions to me. I'm going to guess that we're probably going to have some square roots when we get around to solving this thing. We're coming up with about 0.64899996. All right, if you're having any trouble with this, please get my attention. We'll have some time at the end of class and I can help you out with it. Okay, let's get on to the real business at hand though. Let's solve this thing. So we'll kind of put this aside for right now. We've already got that typed in. We'll use it in a minute. Let's talk about our excluded values. -2 is one of them because why? Yeah, if we put -2 in for x, we're going to end up with a 0 here. And we can't have a 0 in the bottom of the fraction. What's the other thing that would cause us some issues? 0. We can't put 0 in for x either. So -2 and 0 cannot be solutions. What happens if we solve and we get -2 as a solution? We throw it out. It's an extraneous value or solution. We'll just throw it out. All right, so how are we going to solve this? So we need to do some fraction busting on this. I need to cancel my fractions. To do this, I'm going to multiply everything in the equation by some fancy value that's going to make sure everything cancels. And I think of this as the LCD, the least common denominator. If I were going to combine these fractions together, what would my LCD be? I'd say my LCD is going to need an x in it, because that one has an x, and I'm going to say my LCD also needs an x plus 2 in it. And this doesn't have any denominator. Well, it technically has a denominator of 1, but that's kind of built into this already. So my LCD is x times x plus 2, and that's what I'm going to multiply by. So this is going to get a little messy. I'm going to rewrite my equation so I've got some room after everything. And I'm going to multiply everything times x and x minus 2 times x and x minus 2 times x and x minus 2. Should be plus 2, shouldn't it? Thank you. And I copied this down around 2, didn't I? fixed. So we just made our equation more messy, but what's the benefit here? Why? Yeah, we get to cancel now. Now I get to do the fun part. Not everything cancels, but our denominators are all gone. We've got some stuff left. Now, many of you are going to go ahead and just do your distribution straight from this step. I don't do that. I will always write down my factors. And I got a good reason why. Anybody interested in why? Yes. Oop, that canceled. Hang on. It's just 1x. Forgot to cross that out. Sometimes I start talking and I make mistakes. Okay. The reason why is, and we're not going to see this in any of our examples, but let's say this had been a minus here. When I went to distribute, it's really easy to forget to distribute that negative sometimes. And so I found if I write everything out like this, if something does end up having a minus in front of it, I got a much better chance of distributing correctly. That's the reason I do it. It only takes me a second to do it. So anyways, let's finish it up. Now I'm going to distribute. I don't have any negatives to worry about here. But if there were any negatives or minuses in this problem, I would definitely be double checking. Like I said at the beginning, that's probably our most common mistake with these. We're looking at a quadratic equation now, aren't we? How do we solve quadratic equations? We got to get a 0 on one side, and then from there, we hope that it factors. And if it doesn't, then we can either do quadratic formula or we could solve by completing the square. I think I'll go with quadratic formula if we need it. So let's get rid of everything over here. I want to keep this x squared positive. I just find it easier to work with that way. So I'm going to get rid of the 3x and the x and the 6. And I'll see if I can make it factor. I'm guessing it's not going to, but let's see. 6, no. 6 and 1, no. 2 and 3, 2x and 15x, or 10x and 3. Ooh, that's close, but no. Nope, sorry, doesn't factor. So quadratic formula. Yay! We love quadratic formula. Should we all sing? Oh. Aww. Practice for our holiday math caroling. Yeah. Oh, no way. People love that song. All right, B is 6 and A is 5. C is -6. Dun, 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 dun. We got 36 and that's positive 120. So 36 and 120, 156. Seems like something perfect square ought to go into 156, right? 156, 4 does. 4 times 39. Any perfect squares go into 39? 39 is what, 3 and 13? Those are both prime. So yeah. So 4 times 39 is how I'm going to think of that. So -6/10 plus or minus 4 times 39. Running out of room. So that's 2 root 39 all over 10. And we'll do a little simplifying. And I think that's my solution. What do you think? Yeah? So if I type this in the calculator, we're going to get that same decimal that we came up with when we solved with the calculator a second ago. I should have written it down. That was one of them though, wasn't it? And then if I change that plus into a minus, there's the other one. I think my calculator rounded this one to was negative 1.849, wasn't it? Pretty close though. All right. Do we need to throw out either of those solutions? Nope. They weren't part of our bad values or excluded values, so we're good to keep them. All right, what questions do you guys have on that one? Does this seem kind of familiar? Did you do something like this last year? That's it. That's our final answer. X equals, those will be our two solutions. Again, we could go back to our graph and do second calc value just to confirm if we wanted to. I could type in negative 3/5 plus 1/5 times the square root of 39 for my x coordinate and hit enter and hope I get a 0 for the y. Sure do. And I could do the same thing with the minus instead of the plus. So nice thing about solving equations is you can check your answers pretty easily. All right, one more. You guys are doing awesome. Last one. Yeah, let's do, hang on a second. We're gonna make these negative. Actually, that's sort of artificial. I'm not gonna make a negative, sorry. Folks, I picked some great problems, but I really wish that I made some problems where we had a minus in between here. And I just need you to make sure as you start working through these through your assignment, keep an eye out for that. That's where the problems tend to happen. So I wish I'd found one that had a minus instead of a plus here. I was about to just make everything negative, but that's a little artificial. So just keep an eye out for it. What happens is you end up with a minus here and then you distribute the 5 after we end up distributing, but you forget about the minus. You just got to keep an eye out for that. That's why I always do that extra step where I show before I distribute. So I'll show you that in a minute, but let's go through and do our excluded values. We got any bad values here? X can't be equal to negative 3 or 2. And anything that makes this equal to 0. Oh, does it factor into those same factors? Oh, that's convenient. Nice. And so those would have the same restrictions that this does. So, okay, so if we end up with either of those solutions, we're going to throw it out. Say it's extraneous. All right, so let's go through and bust the fractions. What am I going to multiply everything by? LCD would be x plus 3 and x minus 3. Or sorry, x minus 2. That should cancel everything out, right? Let's see. Writing minus 3 instead of minus 2. Right, when we get to cancel. Double. No more denominators. Woohoo! Let's write down what we have left and then multiply it out. This is just my little strategy for not screwing up the negative signs, which this problem doesn't have. That looks like another quadratic. Let's clean it up a little bit. Should we try and factor it? Or should we just go straight for the quadratic formula? Try and factor? Yeah, I mean, if you're comfortable with the quadratic formula, you might decide to just not waste your time trying to factor it, because sometimes they don't. If this one does, it's going to be 2x and x. Do you guys know there's a couple tricks about factoring? I'm not sure what this theorem is called, but this can save you some time. Did you know that if the quadratic does not have a GCF, then you cannot have a GCF in either of your linear factors? So this one does not have a GCF, agreed? That means that neither of my linear factors can have a GCF. There's no way that they possibly can. And here's how that's helpful. I know that like 2x squared can only come from 2x times x. There's a couple ways I can get 10. It could be 2 and 5 or 1 and 10. Let's say I decide to check whether 2 and 5 is going to work. Would I ever check to see if that worked? No, I wouldn't, because this has a GCF and it can't have a GCF because this one didn't have a GCF. So I wouldn't even bother trying that. I would maybe flip it, try the 5 here and the 2 here. Can I make that work? That's 5x. This is 4x, 5x and 4x. Yeah, that'll work if the 4x is negative and the 5x is positive, and it does factor. Cool. So then we can split it up and solve it. 2x plus 5 equals 0 and x minus 2 equals 0. We'll do our algebra steps. If you can do them in your head, more power to you. And there we go. No? What's wrong? Oh, did we get an extraneous solution? So we said that x wasn't allowed to equal 2, but we came up with a solution of 2. Does that mean I made a mistake someplace? No, it doesn't. We did everything right. It's just that sometimes when you do that step to clear fractions, you end up with extraneous solutions. So because of this, we're going to throw this out and write that extraneous. So our only solution is -5/2. How do we check it? Graph it. Get a 0 on one side of this and graph it. We'd be expecting to see one and only one x-intercept, and this is going to give us that. All right. Would this be a hole? It would be an asymptote. Yeah. So when you go to graph it, like if you got a 0 on one side, yeah, you're going to see an asymptote there. Any questions? All right. Let me, this is a weekend, so we want to